Yeah, go ahead.
Well, Anton, thank you so much for helping my project. Could you say a little bit about yourself?
Certainly. I'm a fresh out of undergrad geologist and mathematics dude who's going to be going into grad school for aerospace in the next year. I like space a lot, always have. Super excited to be doing this. I think returning to the moon is something that definitely needs more publicity. It's surprising how often I talk to people and just to find that they've never even heard of it.
Actually, that's been my experience as well. My plan was to interview people at coffee shops, on the street, at the stores.
Sure.
And just out of curiosity, you know what percentage of people I've talked to that know about us going to the moon?
I'm guessing it's well below 10%.
Actually higher than that,
Oh, really?
20%.
Oh,
Yeah,
wow.
yeah.
Wow. That's better than I've gotten, that's for sure.
Now, I have talked to some people that are like, why is NASA hiding it? Um, why
Huh.
why aren't they doing anything on social media about it? Didn't they shut down the space program? You know, I've gotten those kind of comments.
Yeah, that's really unfortunate, but doesn't surprise me at all to hear that.
But I've gotten other people that are really excited about it too. So
Yeah, it seems like, and I imagine you obviously can understand this within the space community, within the people who've been keeping track of, hey, what is NASA doing? What's really going on out there? They're super excited about it. Everybody else is like, I don't even know what the Artemis program is.
um, and it's amazing geology and math. Could you explain that?
Yeah, I've got a spiel. I'm pretty good at it at this point because it's been in a whole bunch of application letters. But basically, there was no engineering program at my university, and I figured I want to be mining asteroids at some point. Which is, if you actually want to get down to the nuts and bolts of that, that is eventually going to lead you to aerospace. Unless you're on the business side of things, which there's a really healthy and interesting community around that. But I figured I like rocks. There's rocks in space. It's pretty much all there is in space, honestly. And anything ISRU is going to involve rocks. And then I also figured, well, I love math as well. And math is the O blood type of the STEM world. So if I'm trying to switch fields mid-career into engineering, I figure being brushed up on math is probably the better way for me. And honestly, it's worked out for me so far. I'm
Well, I'm a math major,
deferred.
so
Oh, really?
yeah.
That's
So
awesome.
I gotta say, that choice adds up.
Yeah. Yeah. That's really
Sorry.
cool. That's really cool. No, I always love running into fellow math people. It's always a rare delight.
So abstract algebra, linear algebra, or calculus. Which would be your favorite?
Oh, if I had to choose.
Yeah.
The calculus is right out of the running, which is bad because I'm trying to go into engineering, but honestly, screw calculus. It's the most boring advanced math field out there. Uh, I mean, until you start getting to the actual interesting stuff, that's the case with anything. Between abstract and linear, I want to say abstract just because it lends itself to topology so rapidly, and like let's be real, that's really where math gets really cool. But at the same time, having sort of a numerical background and just like being moderately ish interested in applications, linear is you can't avoid it. It is everywhere. And it also does have its relationships with, it's more informed by topology than the other way around, but that's a really hard one. I think I'm gonna have to go with linear just because I got a better grade on it, honestly.
Yeah, but I mean, you're right about linear and all the applications. I mean, essentially, a lot of neural networks can be reduced
Oh,
down to,
yeah.
you know,
Well, yeah.
multiple.
I'd say a lot of machine learning. Neural networks really. Like once you start stacking them on top of each other, doesn't it get pretty nonlinear pretty fast?
Well, I guess in the sense that all your connections you could represent as,
Oh, sure.
yeah,
Sure. Yeah, that makes sense.
huge matrices
Yeah.
representing this. I
I'm
mean,
sure you've seen the XKCD about machine learning where it's just throwing numbers onto a pile of matrices and seeing what comes out the bottom.
I haven't seen it, but I could
It's a
imagine
good
it.
one. Yeah, it's a good one.
He's very prolific.
Man's
XKCD.
got his fingers in Randall Monroe. That guy You know, he's got fingers in a lot of pots.
So topography, do you have like a favorite problem that you think about sometime, your go-to?
All right. So truth be told, my introduction to topology was there was a professor I thought was pretty cool. And he had it was like a special seminar or something. And I was like, I don't know, a sophomore or something along those lines. And at the very start of the class, he goes and asks, so everyone's taken real, everyone's taken abstract, you know, right? Everyone's got proofs, and of that, I only had proofs. So I was like, yeah, I haven't had linear, I haven't had abstract, and I haven't had real. So he's like, oh, okay, well, no problem. We'll teach the class down to that level. Long story short, he did not teach the class down to that level. This whole thing was sort of building up to the generalized Stokes theorem. And maybe it wasn't the hardest core topology out there, but you know, for a crash course for a guy who'd never even heard of like internal or exterior forms was that I would love to retake that class now that I feel like I have a clue of what's going on. But it really was, I don't know, it's not like I feel like I'm particularly good at math. In fact, I'd probably imagine I'm below average, but I never really felt necessarily overwhelmed or odd perhaps by concepts until that class, when I was just like, I get that this is super cool and super beautiful, but it's also way over my head. And you know, in some ways, just wanting to really grok the entire build up to the generalized Stokes. Oh man, yeah. So as far as favorite question, but I mean, one of my regrets, or what I anticipate will be a regret, is the fact I'm not going to really be able to pursue too much higher math if I try to get through grad school in any quick period of time or approaching that.
Oh, I don't know about that. You know, in abstract algebra, Abel is one of the big contributors, and he was a lawyer. So
I know, isn't that interesting? There seems to be something going on between law and math students. I've heard that before, and obviously. You know, Abel made his mark.
yeah, no, and indeed. So Grok, Stranger in a Strange Land.
That's right. I don't actually have I read that. I think I read that. I went on a Heinlein bet a while ago. That was one of the weirder ones. It's definitely one of the weirder ones. I think my favorite of Heinlein's work is Moon is a Harsh Mistress, just because you know, I don't know if I like Expanse because I like the Moon as a Harsh Mistress, or I like the Moon as a Harsh Mistress for the same reason I like the Expanse, but it's got some good space dwelling people things going on in there, and I'm a big fan.
Well, how about Firefly and Serenity and that whole thing?
You know, that was a you know, something that is all the brighter for how short it burned. But wonderful. That show is great. It's just one of those things where, you know, kind of, you don't want to get too emotionally invested in it because, you know, there's like what 13 episodes out there, and you know, a B flick, but what it's there is really good. It's really good.
And did you see the reference to it in Big Bang Theory?
Oh, I haven't. I'm afraid I haven't watched that.
Okay, well, you know the characters though.
I know there's a dude named Sheldon. I think that's about it.
Okay, well, anyway, he has like this mega roommate agreement that covers, you know, thermostat settings and
sure.
People will use the bathroom and stuff. Well, in there, it's like every Tuesday night at this time, we will watch Firefly, which will be going on for the next decade, you know?
Yeah, that's understandable, honestly.
Yeah.
That's understandable. Brilliant show.
Yeah, it's a shame. I'd love to bring it back somehow.
Yeah.
But I think that time's passed. I don't see it happening.
Yeah, that's not coming back, unfortunately.
So geology, did you do much field work?
I've done my fair share of field work. In geology, there's, I don't know about, you call it a tradition. It's just part of the education standards. Basically, no matter where you go, you do a field camp, which is say you get out there, you do some mapping. It's sort of like, you know, your real world. This is your geology. Can you learn the theory, you've done the classes, you've done the tests. Can you actually do what a geologist does? And that's sort of, wherever you go, it's like a live out in the middle of nowhere for 6 weeks, mapping some formations out there. And I was able to do that because of COVID, which was really unfortunate. And there's, 2 years of students who either haven't had field camp despite graduating or did it in Minecraft, which that's really tough. But that's not to say I didn't have, my field experience. And since I got a job here in Arizona as a geologist, and I managed to get one without field camp, which was cool. And I've had plenty of field experience since. But if you're asking about what my favorite was, I had the opportunity as an undergrad to go live out on Athabasca Glacier up in Alberta for about a week, I think, about a week, maybe slightly less than that, in the middle of April, which, I wasn't really aware of it. I'd been told, but, it's not like I had any frame of reference. Apparently that's the dead of winter as far as glaciers are concerned. And let me be real, it felt like it. That was a lot of fun, though. I'd do that again in a heartbeat. Not necessarily geology, kind of fast geology, all things glaciology, but, it's nice as a mineral. Glaciers are a rock.
Absolutely. Yeah. And water is just molten ice.
Yeah, I mean, I go bathing in myself in magma. Well, I guess
Exactly.
it's lava since it's been oxygenated, but on the regular.
But you talk about doing the field work out there for what, 6 weeks at a time or several months at a time.
Sure.
I mean, it seems like that would be very kind of COVID friendly. You test everybody, you isolate
Well, it
the
was sort of the
team.
height of the pandemic, and you're bonking around in vans and you're
Hmm.
bonking around in tents and what have you. So I don't know. It's being outdoors is probably better, all things considered. Yet I can imagine if there were an outbreak somehow, like during a field camp, especially because you have to pay like several $1,000s for it, unfortunately, um, between the coursework, because it's still a class technically, even though it happens in the summer, and the travel and the food and the everything. It's not cheap. I just feel
Wow.
bad for the kids that did in Minecraft.
I know. It seems like there might be something a little bit more higher resolution that they could use.
Well, I mean, if you can
I
learn
mean, if
something
all your
about
rocks look
structure,
like
then
this, it's kind of boring.
let's be real. I mean, I'm from the Appalachians. I went to school over in North Carolina, and our outcrops are not much better than that. They are few and far between. Coming out to the American Southwest, eye-opening. It's amazing what geology can be when it's not like you have to rely on the occasional road cut to get a sense of what's actually in the ground. It's just out there, plain to see. It's not everything covered by green stuff. We love the green stuff, but it's more biology than geology.
Can I ask which city you're in?
I am in Tucson right now.
Oh, Tucson. I went
Yep.
there at the end of September for the seventh Interstellar Symposium.
Yeah, I'm actually kind of bitter about that one because I moved right before that. And I didn't realize it was happening. It was like the week I moved here. If I had, or it was like the week after. If I'd known that, I would have been all over it. But I didn't find out till it was over. And let me tell you, man, I'm still a little salty about that.
Do you know Stephen Fleming?
I don't believe I do.
Yeah, he's like he was hosting it, but he teaches at Arizona University of Arizona.
U of
So,
A, yeah. I mean, I'm right next door to them, but frankly, I haven't really interacted with the university that much. Probably something I should do more.
yeah, I was looking over there. They have several buildings dedicated to space science, and one of them, the
Yeah.
Kepler buildings. I went around and walked up and down the halls, and it's just amazing, kind of like the posters and displays they have.
Oh, I'm sure. One of the cool things about the Arizona school system, I should say, is just um, how closely they work with NASA. I mean, you look at the Perseverance program, you look at shoot like the Psyche mission. The PIs are here in the Arizona system. The instruments are being built up in what's it called, Tempe. I mean, it's really cool just how much gets done here.
And the Psyche mission is right up your alley.
Yeah, big fan of that. Now it sounds like So from what I'm aware, and I'm not the most informed on it, we believe Psyche to be a metal, essentially just an iron nickel hunk of metal floating out in the void. But we know that from density estimates. It's not like we've directly observed that. We don't have like any spectrographic data that gives us its composition. It's just a density estimate. And, they have a whole mission designed around, we're going to go see this hunk of metal. We imagine it's the interior of a planet, or at least part of the protoplanet's sort of core. And so it's going to be really valuable for furthering our understanding of how the solar system formed and all that, because geochemistry, well, exogeochemistry, planetary geochemistry. But apparently, I think they did something with Hubble, or they pointed Hubble at it again recently, and they've gotten a different density estimate, which is substantially lower than the previous density estimate. So this might end up not actually being the metal asteroid people thought it was, which, we'll find out for sure in a couple of years. But I can't imagine it's like Dr. Lindsay Tarkin or something like that. I wonder what she's thinking about right now. She's the PI, the ASU person I mentioned. And that's like, man, it'd be a real bummer if this thing just turns out to just be like an oddly dense chondrite or something like that. Still a pretty big one.
I was reading something the other day about cobalt mining in like Africa or something like that.
Sure.
And I was like, are there any asteroids you know of that are cobalt?
That's a good question. I'm gonna have to review my periodic table, but I want to say that cobalt is too heavy to appear on most asteroids. I'm not a planetary geologist. I don't know that much about meteorites and asteroids by extension, but I do know that the number of minerals that's present in the outer solar system, that's present in the asteroid belt, is like, it's a short list. It's like 50 minerals. And I'm pretty sure, you can imagine just really loose sort of order of magnitude calculation. Every time you add a new element to the mix, it's like a factorial sort of thing, because they can combine it in a million different ways, whatever. But I'm pretty sure it's because it's a pretty short list of things that are out there as far as elements go. It's like, your CHON, your carbon, oxygen, nitrogen, hydrogen, obviously, your nickel, your iron. I don't know about cobalt. I really don't. That said, I'm pretty sure if there's a market for mining metals in space and bringing them back down to Earth, I don't think that's going to open up it's probably not going to open up in my lifetime, to be really honest.
Even if Starship's successful?
Well, if Starship is successful, which I'm certain it will be, you heard that weird tweet about Elon Musk is like, oh, we're about to go bankrupt.
Well, no, he said that he can see a scenario where they might go bankrupt.
Sure, whatever. That's not going to happen. That's not going to happen. Sure. At a minimum, he's going to be like, all right, well, somehow we've managed to work ourselves into the most dire financial straits. So we're going to open up as a public, we're going to IPO. And I fully expect if they IPO SpaceX, it's just going to absolutely blow up. Probably set some records along the way. So they've got no shortage of funding. Not to mention, they've just won like one of the NSSF contracts or something like that. One of the ones they're in competition with Blue Origin, I want to say. Oh,
you're talking about the human landing system.
No, I'm talking about the Space Force contracts.
Oh, Space Force.
Yeah, I'm pretty sure just one of the big Space Force contracts, and they're in running for like phase 2 of it or something like that. I don't know the exact details. That's an Anthony Colangelo question. But the reason I don't think that we're going to be seeing asteroid mining happening is just for simple delta V requirements. And I don't think we're going to get to the point where you can have like, it's a ludicrous amount of energy you're going to need to send an asteroid our way. So either you do it for minimum delta V, and it's like takes 25 years for you to get your asteroid here, which I could see that working, but for there to be a financial case where it actually happens, as opposed to it can happen, because it can happen, but will somebody actually do it? Is it profitable? We still live in a capitalist society. I can't imagine us not anytime soon. So it's not going to happen until someone thinks I can make money off of it. Not my kids can make money off it, but I can make money off of it. So honestly, I don't think it's going to start happening until you have an ecosystem in space. You have space infrastructure that's being built in space from resources in space, and it becomes cheaper to say, I'm going to do, whatever actuarial nonsense it takes to estimate the value, risk, whatever, of flinging an asteroid here. How much is that going to be worth in 25 years? As opposed to, hauling stuff up from Earth for 25 years waiting for the asteroid to get here, or more realistically, material sourced from lunar regolith, because that's what I think is going to be the next step.
Yeah, especially with the way technology changes. If you're
Oh yeah, I mean, it's incredible. The pace of things is like, especially if I mean, I don't know how in tune you are with the whole fusion thing. You've been keeping
not
your
that
eye on the
much, but I
headlines.
was just thinking fusion. I mean, if you could fuse
Yeah.
any atoms together that you want to create any type of element, then who cares? It's
I mean,
all
I don't know
about
about
energy.
that. I was just thinking as far as like engine tech, propulsion technology goes. I mean, if nuclear engines, which are starting to be reinvested in by Space Force, that technology, it's not mature, but it exists. We could have fusion engines. We could have nuclear light bulbs in the like within 10 years, functional prototypes on orbit, 15 years in commercial applications. If we decided we wanted to go that way as a nation, that would change the face immediately of what we think of when we think of things that happen in space, because now you're talking, you just need water, you just need some sort of mass distilling out the back, and you're looking at delta V that we would never have before. I mean, that's like one technology that would make a manned Mars mission almost immediately feasible. And obviously there's still some hurdles in the way. You can't talk about going to Mars without talking about the human factor. You can't talk about it without radiation costs and all this, but you can brute force it. If you have engines that are this powerful, you can say, well, maybe we don't know what the radiation load is actually going to be. Maybe we don't know what the safety limits are for astronauts. But if we can just surround everything in an inch of lead, we don't have to worry. And we can do that because we've got nuclear engines. Fusion would change the game all over again. In fusion, again, I'm skeptical. I personally think it will happen in my lifetime. I think I might be on the better end of 80, 90 at that point. But I think fusion is definitely going to happen soon. And it's one of those technologies. I like to talk a lot about technologies that people have been looking forward to for a long time. We know they're going to be revolutionary, but it's hard to anticipate the secondary and tertiary effects of those revolutionary technologies. For example, microprocessors, the invention of, I can't remember the name of the thing, like the solid state transistor, essentially. It was known when some sort of miniaturized transistor comes into existence, computing is going to be revolutionized. People knew this back in the 30s, back in the 20s, whatever. When they were first thinking, they hadn't even built computers yet. It's obvious there's going to be some sort of exponential growth. Moore's law didn't exist. There's going to be some sort of exponential growth in computing capability. And, it's like robots. That's a pretty natural thing you could think of. What people didn't think of is the internet's going to merge. Social media is going to merge. And I would say the cultural revolution that has occurred in the past generation and a half, as far as speed and extent, the fact that, the entire world is connected, the entire world is to some extent speaking the same language on the same platform. I don't think anybody could have seen the cultural side effects of inventing the transistor, the solid state transistor. On the same side, and this is an example I like to give, it's kind of talking about unknown unknowns. So it's hard to really be like, this is what's going to happen. But I like to talk about fusion and its impact on fossil fuels, because we have the technology today to pull carbon dioxide out of the atmosphere and convert it into hydrocarbons. It exists. China's doing it right now in these gigantic, like tree looking things or something. I don't know. They're like big towers. I think even Canada is doing
that
it
on Mars too.
Oh yeah. I mean, it's a thing. Like it exists. What's it called, like Sabatier process or something like that. Yeah. But it's energy prohibitive. There's no reason to do it besides taking CO2 out of the atmosphere, because it takes way more energy to do than it gives you in return in hydrocarbons. There's no such thing as free lunch. Well, if cold fusion comes around, and suddenly the entire planet has more energy than we know what to do with, you can literally undo the clock on what's happened as far as the greenhouse effect, as far as climate change has happened. As soon as you have that level of free power, you can just say, oh, you know what? We'll take the last 100 years of carbon emissions out of the atmosphere, and we're going to turn them into hydrocarbons. You can still have your internal combustion engines. You can still have your aviation fuel. You don't have to have everything be batteries. I mean, it would that's not something that people talk about when they talk about cold fusion frequently. And, it's a pretty limited example, but it is something that I like to consider. And so as far as space travel goes, it's one of those things where it's like cold fusion comes around. Who knows what is going to happen in 50 years in space flight? That is a super exciting prospect to me. And I can't even speculate. I'm just, it's like, I'm excited.
Well, I was even thinking if you had technology to take carbon out of the air and use it to manufacture stuff, you actually are building buildings sort of organically.
Yeah.
At some point there actually may be a lack of carbon in the air. Like the carbon credit will be, if you put carbon in the air, we'll pay you.
That's funny. I could possibly see that. I personally think the biosphere is just too rich for that to happen. But somewhere down the line, that carbon's rare. Carbon is a very uncommon element. Well, maybe not very uncommon. Oxygen is really uncommon. We have a lot of that. So I don't know. On Earth, we're kind of topsy-turvy. Most places have a lot of carbon and very little oxygen, but at least our crust, quite the opposite. I mean, we still have a lot of oxygen, but I mean, I don't know. It's the Earth. We're special.
We are, but maybe not that special. At least for our system, we're special.
I mean, frankly, and I don't know if we got time to get into the Fermi Paradox sort of thing, but it's kind of weird. You'd expect to see something blotting out suns out there, but
the interesting thing, I was talking to my wife went down to Mexico City.
Sure.
The head of Aztec Empire, and we were just talking today. And apparently, like whenever Christopher Columbus sailed to Puerto Rico.
Sure. Like second journey or something like that. First journey, I don't remember.
I think it's the first journey, but I'm not entirely sure. But my understanding is that the natives didn't even recognize those things as being boats.
Oh, that's what I've heard.
That they thought they were like clouds or something. They didn't even pay any attention to it.
Yeah.
It's very possibly we're surrounded by aliens and we just lack the mental capability of imagining what we're seeing.
Yeah, that I could see that. I mean, there's arguments for why that could or couldn't be the case, but I think it'd be grossly presumptuous to imagine that anybody could possibly rule that out. It's just sometimes I feel like if you want to talk about things, it has to be falsifiable, otherwise it's not exactly speculation. I guess it's just kind of, fantasizing, I suppose. I don't know. Like, you're right. There very well could be aliens among us right now, and we'd never know, just because they exist in some state that we don't perceive, or we can't anticipate them. Maybe dark matter is aliens. I don't know. But is that something falsifiable? Can we prove it one way or another? And so by extension, is it that worth, is it productive? I don't know. These are philosophical questions I tend to not ponder.
But I mean, if you think about the invention of the radio was what, 150 years ago?
Yeah. Yeah. I mean,
theoretically, we weren't really detectable as technologically, at least from our ability to detect, until about 150 years ago.
Yeah. I mean, we never would have known, which is actually interesting because how familiar sorry, I'm getting over my words here. How familiar are you with the discovery of the cosmic microwave background radiation?
Sadly, my only understanding of it comes from the three body problem. I don't know if you read that novel.
Oh yeah, I've actually got that book on my shelf right now. I picked it up in an airport when I had like a several-hour layover.
Yeah, and in it, it kind of gets manipulated to drive people crazy. I don't know how far into it you got it.
Oh yeah, I remember that. That is
So
interesting.
fun.
Yeah, no, I finished it. It's a good book. Of course, the mathematician side has problems with the way they describe the, unpredictability of three body problems. But besides that, it's an excellent book. It's an excellent book. And I find it really cool. Just, Chinese sci-fi is, they come to the table a whole different set of storytelling motifs, I guess. Reading foreign literature is always really cool. What do you
Yeah,
think of the
or
book?
even Netflix. I don't know if you've seen the
Yeah.
Wandering Earth.
Oh yeah, that's that was like Jupiter and something's going on, and Earth's leaving the sun or something like that.
Yeah,
Yeah,
exactly.
I haven't seen that. I haven't seen that. But I'll also confess I don't watch that much stuff on Netflix, unfortunately. I probably should. I should
Uh,
watch that.
well, I kind of like it the way you're spending your time. So you keep going down that path.
Well, I'm telling you, like, I haven't even seen Tremors, and I'm a geologist. Like, I'm practically not even in the field. I've heard it's shitty in a great way. I haven't seen it
I've
yet.
not seen it or heard of it, so I'll have to check it out.
It's like giant worms under the ground, and they eat people and make earthquakes and stuff.
I think you're thinking about Dune. No, just kidding.
No, no, I'm pretty sure.
Uh, is there any spice in it? No. A
I think there's a lot of shotguns.
lot of shotguns. Okay.
Yeah,
Yeah. No, the three body problem though provides an answer to the Fermi paradox.
yeah,
That basically people are so other species are so concerned about competition
hmm,
that anytime they see somebody coming up, they kill them. And so
yeah,
the only ones that are out there are the ones that can hide.
yeah. I don't like that answer. I don't
I
like
don't
that answer at
either.
all.
I don't either.
How familiar are you with the YouTuber? I think his name is Isaac Arthur.
Oh yes, yes.
Yeah,
I've seen him. He has some really good videos.
he does a lot on the Fermi Paradox. I'm pretty sure he's got a video about that, like aggressive, like I don't remember what it is. He's got a whole series. I don't know if I've seen that one, but there's a lot of answers out there. Some of them are really shitty answers. Others are startlingly plausible. Personally, I just think the answer is the Fermi paradox is a paradox. And I don't know. I tend to think we're one of the first species out there, at least in our sector of the woods, that's
Yeah,
gotten
I
as
mean,
far as we have.
there's basically two answers. One is we're the only life around here, or two, there is other life around here, but both of them lead to the same action, like humanity
Yeah.
should expand. Phew.
Yeah. Yeah. I mean, it's reductionistic, but that's physics for you. Um, yeah, there's sort of a simple way you can walk through it that leads you to this concept that, I guess we're probably one of the first ones, namely, if you have a technological civilization, right? Something that has evolved to use tools, things that aren't just biological to help them survive. It gives them an evolutionary edge. Then there has to be some sort of evolutionary force that drove that. Otherwise, we'd be bumping around as bacteria or maybe like slightly more sophisticated amoeba or something like that. So there has to be some sort of competition. There has to be natural selection. Natural selection doesn't occur unless there is selection, generally by competition. And if something has competed its way to the top of the evolutionary pile, it's going to continue to be competitive. It's going to continue to be expansionistic, all the traits that we may or may not love about humanity. And it stands to reason they would continue this behavior once they get out amongst the stars. There's no reason it would halt. And then it's like, well, Dyson spheres make a lot of sense if your energy consumption requirements aren't going to go anywhere, and the number one energy source in the universe is stars. So if you want to get energy out of stars, you're going to absorb that energy, and if you absorb that energy, some amount of that's going to be radiated back as black body radiation. But the point is, it's not going to be in visible light and ultraviolet and all that. It's going to be much lower wavelengths, and you're going to see stars blotting out and becoming infrared across the sky. And if you think about humanity's advancement, I mean, we like, when did we discover fire? Like 4 million years ago, something like that. That's like what we think. 4 million years to where we are now is a blink of an eye from a geological standpoint, from the standpoint of the universe. I mean, it is nothing. It is the last 20 seconds on the full day of the histories of the universe's history. It might even be less. I don't know. And you think about what's going to happen from today, you know, you look back at where we first took flight. That was what, just over a century ago now, like 110 years or something like that. And we're talking about going back to the moon. We're talking serious about cold fusion, all this stuff. I can't imagine what the next century holds. I can't imagine what the next 100,000 years hold. I can't conceive of what a million years of humanity is going to look like, assuming we get that far. So 5 million years maybe between we discover fire, we become a technological civilization, to, if you want to do the math, even if you're traveling out at like a fraction, tiny fraction of the speed of like 2% of the speed of light, I think the time it takes, and let's say it takes you like a million years, or I don't know, 100,000 years or something, like set up a colony on another planet, we could still cover the entire Milky Way in, I think, like 30 million years, just back of the envelope math. Again, just a moment in geologic time. So the question stands, why hasn't somebody else done it? Anywhere in the Milky Way. Why hasn't somebody else done it yet?
Absolutely.
Why aren't we watching Andromeda or some semi-nearby galaxy slowly go dark as aliens build Dyson spheres over every star? It's
You know what you just discovered? You discovered the answer about dark matter.
I mean, that actually, I think somebody has suggested that. I think there's been a very serious suggestion that dark matter is Dyson sphere stars. Now, I'm not super fond of that suggestion for a handful of reasons, but because like the whole thing about dark matter is, for galaxies to look the way they do, you need a blob, like a ellipsoidal blob of mass distributed around the galaxy, as opposed to a disk. And that leads you to the first assumption about dark matter, namely it doesn't interact with the electromagnetic force, or I guess the electroweak force, because otherwise, just like the processes that formed an amorphous blob of elliptical galaxy into a disc-shaped blob of spiral galaxy, you'd have collisions between matter. Collisions aren't going to happen unless there's a collision, and that's electromagnetic force, as far as we're aware, which eventually will turn ellipsoidal blobs of mass distribution into flat two-dimensional sphere disks of mass distribution. So that's like the first assumption about dark matter, is it doesn't interact with the electromagnetic force, and I don't think that'd work for stars covered in Dyson swarms, but like, what do I know?
I know. I mean,
these are questions that it's incredible. We live in such an era of mystery.
But so one little counter trend I'd like to just put out there and get your take on. So as countries have become more wealthy, they have produced less children. In fact, the native-born, rate in the Western world is not enough to replace what's there.
Yeah.
And in fact, if you look at Japan, their total population is actually decreasing.
I mean, I think, again, going back to the reductionistic first principles sort of evolutionary concept, all it takes is one culture to emerge that says, we're gonna have a fuck ton of babies, and give it a couple generations, give it 100 years. By simple math, you're gonna have a whole lot more of that culture than anybody else.
I think you're starting to see maybe the thinking of the leaders of the Catholic Church and Islam.
I'm the oldest of 6 kids, and I had a lot of family friends growing up, 11, 8, 9 kids. So I'm maybe not Catholic, but certainly no stranger to the quiverful philosophy.
Yeah, my cousin, she has 6 kids too, and One thing is, and about large families, um, I think they learn a lot more, uh, interpersonal, like community skills that smaller families don't have.
That may or may not be the case. I couldn't tell you from personal experience. I will tell you I wouldn't trade my family for the world. Um, yeah, I mean, I personally feel very blessed to have be part of a large family, but maybe when I was 14 years old, I wouldn't have felt the same way.
Yeah, I know. I mean, you probably fight a lot with your siblings, but on some level, there's like, um, I mean, you would do anything to protect them.
Oh yeah, I love them all dearly. They're all amazing people. And again, I think it's really cool that I have them in my life. It's family is one of those things where, taking a complete detour from space exploration. Family is one of those things where, it can be really horrific. I've seen it. People who've had to cut their families off completely, but at the same time, when your family members aren't d-bags, it's really cool to have that intimate relationship with what otherwise would be a total stranger. There's nothing inherent about that. Like, there's no reason that you have to know these individuals so closely. If you do, like, that's a really cool thing. It's almost a gift. I don't know. I find it
And
cool.
absolutely. And I think to some extent, kind of like these wars of the past, like World War II, for example, like you see these soldiers in like foxholes together and helping each other.
Hmm.
In
Yeah.
some way, they kind of like bond together at that
Yeah.
same level, I think.
Yeah. Yeah. I would definitely agree with that. I would definitely agree with that.
And I think these explorers that go to set up that million person base on Mars will have a similar type of experience.
I completely agree with you. And I personally think that one of the great tragedies of the modern era has been the loss of small community. I think humans are hardwired to flourish in that sort of small community environment. I mean, you hear these, I don't know how credible they are, but you hear this pop science fact. It's like, oh, you can only remember 100 people intimately. You can only know a thousand faces or something like that, some sort of order of magnitude estimation. I can imagine there's something to that. I personally think, this is my hot take. I personally think humanity is destined to live among the stars. And this is why. Because you get yourself in your, what are those things called? The big tubes? There's a name for them.
Like the
Rotating,
big
like,
chips.
rotating habitats. What are those called?
Oh, you're talking about
Who's the guy that came up with those? I'm gonna look it up.
it's oh, Gerald
Rotating space.
O'Neill
Yeah,
cylinder.
O'Neill cylinders. That's one. Yeah, you get O'Neill cylinders. It's like pick your O'Neill cylinder size, like 1,000, 10,000, maybe 100,000 people living on one of these. But it's kind of it's like sovereign ground in a way where you can't attack, you can't enforce your will over an O'Neill cylinder from without. You can destroy it, sure, but you can't enforce your will over it. It can't be captured. It can't be overtaken. Besides like societal drift and propaganda or whatever. But I think that's pretty cool because it kind of means that you'll have the self-organizing society where people can essentially put themselves in whichever microcosm of humanity they prefer. And sort of a sort of your libertarian ideal, if you will. But I personally think it's going to be really cool where there's going to be no lack of abundance of land. There's going to be no lack of abundance of diversity of different types of people out there. I don't know. I'm really excited about people living in orbit around the sun in O'Neill cylinders. I think that's a really good end game. Like, okay, I haven't thought about this very much, but for a handful of reasons, I think it's really neat. So like that small
And
city sized population.
and that's what we use the asteroids to build.
Exactly. Exactly.
I know it's really cool is, if you're able to move them around using fusion uh, power, you can bring them close to Earth, load
Hmm.
them up with people, then move them
Hmm.
out to wherever you want.
Yeah, absolutely. Oh, of course, on these time scales, you might as well just use solar sails. But I mean, if fusion happens, game changing. Cannot wait to see how that's going to work. It's going to be phenomenal. I mean, you're talking ISPs in like the 22,000 range. It's just ridiculous. Like the mass fractions you can get are absurd. It's like 50% propellant. That's ridiculous. I mean, the like most upper stages these days are like what, 90% propellant at worst. You know, Centaur is like what, 95 or something like that. I mean, fusion's cool. Fusion's really cool.
I see you light up whenever you talk about fusion.
I like,
Uh,
yeah.
have you thought about making it happen?
Um, when it comes to nuclear physics, I feel like they've got some pretty smart people working on that one. And I'm not gonna lie, standard model stresses me out. I have to learn a whole lot about quantum field theory to really know all that, which I would like. I would love to learn a lot about quantum field theory. I think that'd be an excellent thing to learn about. But what I don't see is a whole bunch of people working on ISRU, which is just as essential for building space infrastructure as fusion, and a whole lot more underdeveloped. You know, people have been thinking about fusion for as long as they've been thinking about fission, pretty much. So half a century or more. But people haven't been thinking about how to build things in space out of the things that are already in space. So that's what I'm personally interested in. Full disclosure. And that's one of the reasons I'm super excited about the Artemis program, because that's one of its primary goals is ISRU on the moon.
Absolutely. I mean, the moment we start building stuff on the moon, I mean, the moment you start creating the system that can go and mine material and build useful things, I mean, forget about the fusion, rocket even. It just beam it up and have it built there.
Yeah. No, it's super exciting stuff. It's really exciting stuff. Have you read this paper? I probably have it printed out somewhere. It's this paper by a guy from the School of Mines. I think his name's what is his name? I'm gonna look that up. He's the lead of the School of Mines Space Resources Program. CSM. What's his name? Faculty. It's a really cool paper. I think it was released in 2019. Should definitely worth a read. Space Resources Program. Where's your people tab? Abu Madrid. That's the guy. Angel Abu Madrid. He, with George Sowers, who's also part of the program at School of Mines, a bunch of people from United Launch Alliance, a handful of people from NASA, JAXA, CSA, like, you know, the whole crowd got together. The authorship is a paragraph. It's like 20 lines of people. There's probably like 50 authors on this paper. It's this massive tome detailing ISRU for space propellant production. We'll say production, distribution, and storage, making hydrolox from lunar regolith, moving it into low Earth orbit, storing it in space depots, and using that as a fuel depot for deep space missions. And it's comprehensive. Like this is and people are working towards this actively. If you go on the list of NASA grants, because those are all public, you can keep an eye on what NASA is funding, and you just search like ISRU, or you search like propellant, or you search like regolith or something like that, and you'll see all these different funded projects, which are research is coming out of them. Let's build something that takes a lunar regolith analog and makes a little tent over it and heats it up in the sun, and you get hydrogen, you get oxygen, you get water out of all this. You can electrolyze it. This is going to happen. Now, I don't know if the money's there yet, and honestly, I'm not gonna say I'm worried about Starship, but I could see how Starship would fill this gap in the market, at least temporarily, which might set this whole thing back 20 years or something. But I don't know. I feel like NASA's got a pretty good, at least the current leadership, and the leadership from the past administration too, has got a pretty good feel on how to both encourage private industry to really innovate and to support them in that without becoming too tightly bound to them. They're not putting all their eggs in one basket. And I think they also recognize they'll use industry, but they also want to be leaders in their own right. So I'm pretty optimistic about the whole thing. Lockheed Martin was also deeply involved, which makes sense because it's United Launch Alliance, but it's really cool stuff. It's definitely worth a read. It is a long paper.
What is the name of the paper?
Let me pull it up.
Because I was looking at his website on the Colorado School of Mines and
graduate generic documents. No. Advisor search. No. Maybe I have it written down.
Space and Planetary Resources.
Yeah, that's the program. It's a pretty cool program, actually. It's called REACH. REACHE. Let's see what Google Scholars come about anything. Abud Madrid. I don't know how to spell that. Commercial Lunar Propellant Architecture, a collaborative study of lunar propellant production. 2019. It's freely available on osti.gov. And it's only 11 megabytes for a PDF. I can read that off again if you want. Or I'll just drop a link.
Copy link. That's even better.
Yeah, we can do this. We can be sophisticated. There you go. It's in the link. Or it's in the Zoom chat. Definitely a good read. If you're interested in sci-fi, this is super hella sci-fi, but it's also, very much the near future. If things go right, if the Artemis program continues to receive funding, the next administration doesn't slash the budget for it. The things that this paper talks about are going to get tested, and eventually, that's the first step for anything. Once you've sort of put you've gotten some experience, some extra expertise, the people that were involved in that disseminate into industry and they make it happen. So fingers crossed that Artemis doesn't get defunded. But I think NASA just bought SLSs through 31. I think that was like news today. They purchased or ordered 8 more SLSs. So that's a big plus for Artemis.
Like today?
Yeah, I think it was today or yesterday. Sorry.
Wow. I hadn't heard anything about that.
Yeah, it's a big win. Oh, 3 days ago. Released December 2nd. 9 SLS flights. Okay, so it was a contract for Northrop Grumman to build the solids.
Okay.
$3 billion contract. All the way through Artemis 8. And have you heard about the Bully boosters? It's like this carbon wrapped experimental new type of solid motor. And apparently this is part of that contract. They're actually going to make it happen. It's not just a concept anymore.
I have not.
Yeah, it's pretty cool. It's like some lighter weight technology. It's sort of like you take the crystal, the propellant crystal that is the heart of the solid rocket motor, and so normally the way you make a solid, especially these segmented ones, is you have a big tin can, essentially, it's made of aluminum, whatever, and you pour your molten propellant into it with some sort of mold to make sure that the interior cavity is the right shape so it burns the way you want it to. And then you cool it really slowly so it crystallizes properly. There's no air bubbles in it, stuff like that. And there's a whole X-raying process to make sure it's perfect. But the way this works, I think I might be wrong. The way this carbon wrap thing is, it's sort of the same thing, but they have a woven mesh of carbon fiber. They wrap it in, so you can cut it and something like that. It's cheaper and better. I don't know. It's different.
That's cool. That should be, doing the same thing we've been doing since the late 1960s in terms of building.
I know, it's incredible.
Late 1970s, I guess. In terms of building shuttle boosters.
Yeah, there really hasn't been that much innovation in solids technology in a long time, I'm pretty sure.
Yeah, I think Estes might have done the
all the heavy lifting. Honestly, I wouldn't be surprised if you're not even joking. You might be right about that. Model rocketry has gotten really big.
Yeah, and plus they have these thrust vector controlled rockets BTS.
Well, I guess I guess technically isn't. What didn't the shuttle boosters do that too?
I don't think
I think they
the
did.
solid rocket had any control. I think
No,
it
the
was,
solid rocket motors did have pit. I know they had roll. I guess they had 3-axis authority. I think what they did, because have you seen the Titan 2s or Titan 3s?
uh,
They don't exist anymore, obviously, but the motors, the solids on the side had these like weird red canisters attached to them. Those canisters were full of something with nitrogen in it. I don't know what it was, but the point was they injected it, like had a whole bunch of nozzles pointing at the throat of the solid rocket motor, and they would shoot the stuff into it, and it would like inhibit the burn or accelerate the burn or something. And it was sort of like this really weird thrust vectoring system. But then for the shuttles, I think they actually had the nozzles,
oh,
like
really?
the throat.
Because
I think the entire throat assembly actually gimbaled. I'm pretty sure.
really,
I'm pretty
for
sure.
some reason, I thought all the control was from the main shuttle engines.
I don't think that'd be possible. I mean, the thrust was like 80% solids. I don't think that would have been controllable. I don't know.
Like, you know, you
I know they controlled though. I know they were controlled. I'm pretty sure. I'm gonna
okay.
look it up.
Well, um, it's pretty much just offsetting the massive weight of the external tank.
Oh yeah. I mean, the shuttle was such a wild design.
I really missed it though. I really miss it now.
I know. I wish I'd seen more of the launches. I only saw 2. Um,
It's two more than I saw.
oh, really? You didn't see the shuttle launch at all? I mean, for
No,
what it's worth, I was like
you know what my
9 years
very
old.
first rocket launch was?
What was it?
Inspiration 4.
Are you kidding me?
I'm
I was
not
there for
kidding.
that. No, I wasn't. I was there for Crew 1 or Crew DM or
Well,
something like that.
I
You were there
was
for
there
Inspiration
for
4?
I was there for the first attempt of Crew 1.
Oh, yeah.
Unfortunately, it looked like it was going to be bad during the weekend, and my son had
Yeah.
AP test the next week, and
My condolences.
he came back.
Story time. There's like 4 Delta 4 heavy launches. 2 of them are now done. Maybe 3. It might just be the last one from the Cape now. But the first one was like NSSF 41 or something like that. I remember. They're putting some spy sat into orbit. I went down to the Cape 3 times. I went down to the Cape 3 times. I drove from North Carolina 3 times to go see this thing launch. And I stayed like, it was like you got there on a Friday and you like sort of called your boss and like put off work all the way through like Tuesday or something or another. It got scrubbed every time.
Oh my
I
god!
was pissed.
Now
I really want to see a Delta 4 heavy launch. Like, I don't know when I'm gonna get the chance.
now the first time I visited Kennedy Space Center was December 1985, and Challenger was on the launch pad.
Oh, which flight? 50, it wasn't 52, was it?
It was,
Oh my God.
yeah.
That's sobering. Well, on that note, one of the 2, and I think the last shuttle I saw launch was 107, which is really weird. Because you hear about the thing breaking up over Texas, and you're like, well, I saw that thing go up. That was really weird. I mean, I was only like 9 at the time, so it's not like I was that aware of it, but still, I was aware enough to know it's pretty messed up. That was like 5. I was really young. It's
Yeah,
2003. Holy
2003.
shit. Yeah.
Wow. So you were born in 98?
98. Yeah. 23.
Okay. Yeah, my older son was born in 98.
Racing to the moon then.
Yeah. Yeah. He wants to make people live longer, so
That's a good thing. That's
that's what
definitely
we
a
need.
good thing.
He's like, that's what you need to be focused on. Forget
Is he
about going.
like biomed, or what does he do?
I mean, he did a degree at CMU in let's see, computational biology,
Oh, that's pretty
and
cool stuff.
so he's been working on. Right now, he's working on like a smart toilet, kind of analyze stuff that comes out of you and finds problems earlier.
That is really interesting. I've not heard of that.
Yeah.
It makes a lot of sense though. You hear a lot about gut microbiome and like what's it called? Colon microbiome stuff. That's really neat.
Yeah, it's amazing. Yeah, just optimizing that might give you a lot of boost.
That's incredible. I mean, that's one of the scary things, or scary, I guess is one way of putting it. That's one of the astonishing things about science and about ourselves, really, is we are such incredibly sophisticated and complex machines, if you will. And we are so poorly understood. We are so poorly understood. It's incredible. I mean, it's you hear these things where like you can't even compute how a protein folds, a single protein, even the simple ones, because the quantum mechanics and the electromagnetic field theory and whatever, your quantum, what's it called? Quantum electrodynamics. They're so complex, you can't model them accurately enough. And yet these proteins are massive. They're like, they're huge as far as molecules are concerned. And yet the way they fold is, it requires this really weird stuff that is not in classical models, or not even like early quantum models. It's like only in our most sophisticated understanding of quantum mechanics can we accurately predict how these things work. And as a result, the computational power is prohibitive even today. It's remarkable. I think that's one of the first things they're probably going to put quantum computers to work doing. Probably. I don't know. But I mean, that's just one protein. Like, imagine trying to model an entire cell, a single cell, and you've got what, trillions of them? That is so weird to me. That is so weird to me.
If we had people spending their time doing that instead of trying to predict movement and asset prices, probably be a lot further along.
Well,
I mean, think about how much computer power is
it's a
being
necessary
spent on
evil. That's true. I mean, I don't. We could occupy Wall Street computation.
Yeah.
Be like, give us your mainframes. Let's fold proteins on them. But I think that'd probably go over about as well as the last one, unfortunately.
I think I saw some type of overlap between like the folded home protein modeling and crypto. Like, I think you would get a certain number of Doge coins for putting your computer to work on.
Interesting.
Something like that. But I mean, wouldn't that be cool though, if you could take like model crypto in such a way that the solution was the answer to protein folding? Like,
that's a really interesting idea, actually.
Kind of create.
I mean, that is an NP hard problem, isn't it? Because see, it's probably really easy to verify that a folded protein is what it's supposed to be, but it's definitely computationally difficult to fold it. So you could probably do that. Now, maybe it wouldn't work because it's not, the whole like RSA, non-blocking locks and whatever. I don't know enough about crypto, but that's interesting.
Either. I sort of have.
That's
like
really interesting. You should write the white paper. The really low-tech white paper.
Well, it's sort of like what is it? CAPTCHA 2, where they actually, took all these scanned pictures of books and basically, give you two words, one that they know for sure, and the other one that they're trying to figure out.
Sure.
And as you type it in, they're like making their progress down all these texts.
Yeah.
I think that's brilliant.
Really neat. That's really neat. I like that.
Now, imagine we could do something like that with the stock market. It's really a simulation of a cell that you're seeing every day.
Yeah. Yeah. Stock market's something else, man. It is something else.
It is. Well, anyway, I got one question for you.
Sure.
If it was safe and affordable, would you go to space?
Oh, in a heartbeat. I'd go if it was dangerous and expensive.
So would you see yourself as being like one of those first colonists on Mars? Like
I would,
Elon?
if they'd take me, sure, yeah.
It seems like you would be their ideal person.
I like rocks. I like living in weird conditions. I got no problem with it.
What's the weirdest conditions you lived in?
I mean, I guess the glacier counts.
Okay.
But
and how long were you there for?
Oh, like a week. It wasn't that bad. And I was actually talking about it with somebody, and they pointed out quite astutely. I would say that I probably look upon it so fondly because it was short. Maybe if it was longer, I'd be like, the glacier. I'm never going back into anywhere cold again.
You're eating the same rations for like 2 years. You know, every
I
time
mean,
you
our
go out,
rations, our rations were chocolate and cured meats because they didn't freeze easily and they're high caloric density. So, if we get chocolate and cured meats on Mars, I think I'd probably be fine. And
that's
cheese, a
pretty
lot of cheese.
that's pretty awesome. I see these series of interviews as being kind of a way for people yet unborn, like your great grandchildren on Mars. Like your great granddaughter has a project to do on what were humans thinking before we took those next steps on the moon.
Yeah.
I think based upon the conversation so far, she's likely to get an A already. But is there anything you want to say to kind of top her over?
I'll put it this way. If my grandkids are living on Mars, I think I'm gonna have a hat to eat because personally, I am bearish on humans living on Mars. I think we're gonna be living in orbit first for a variety of reasons. The only real compelling reason I can think of to live on a planet rather than living in orbit is it's half the radiation load. But aside from that, what really is there on Mars? Besides cool rocks, really cool rocks, I'm sure. Probably not as cool as the ones on Earth, but they're different. I don't know. I see humans living on orbit permanently before I see humans living on Mars permanently. But I don't know how much money I'd put on that. Probably not a lot. So there you go. There's a little pre-space pre-space habitation pessimism
No,
about
no,
the
I mean, it's
future.
brilliant though, because I mean, it solves the problem of how do we know that there was life on Mars before we got there, right? I mean, if we're just like creating big habitats or orbiting around
Yeah.
Mars, we get to study it all the time, send the robots down,
Yeah.
you
I mean,
know.
I think fundamentally it's just there's not a lot on Mars. There's not a lot of gravity. There's not a lot of atmosphere. There's not a lot of sun. There's just not a lot on Mars. It'd be like living on a weird light version of Antarctica, which people don't do. I could see us living on Venus, on aerostats in the Venusian atmosphere before I see us living on Mars. I don't know. It makes more sense to me. You've got Earth-like pressure. You've got tons of sun, all the energy you could ask for. You've got Earth-like gravity. That seems a lot more hospitable to me than cold, uh, almost near cold near vacuum and low gravity.
And if we get good at taking stuff out of the atmospheres, maybe we'll make it into whatever we want to.
Yeah, perhaps. I mean, the planet's really big. So something like that would probably take about 1,000 years. But I mean, shoot, I mean, people have done weirder shit. I could see it happening somewhere down the line. Yeah, I can't imagine what technology is going to look like in 1,000 years. I mean, do you think that? I mean, I can barely conceive of what technology was like 1,000 years ago. People living in the year 1000, would they have any modicum of an idea of what we do in our daily lives right now? The fact that we're having this conversation. I mean, where you are,
They'd be
you're down in
like,
Houston.
this is a weird shaped rock. I don't know what I
I
use it
know,
for.
I know. But the weird shaped rock is one thing. The manufacturing required to make this thing at
Mhm.
scale, that's what blows my mind.
Yeah.
I don't know how, I mean, just the way you make memory, the printing, the detail. This is like single atom etching that goes into making these microchips. People don't even know what an atom was. Greeks had some philosophical idea, whatever. That's not an atom. They didn't know what an atom was. And now it's incredible to me. It's
Now we
incredible. I
tear them
can't,
apart, fuse them together.
I mean, it's gotten to the
Yeah.
point where it's cheaper, it's more efficient to throw these away and buy a new one than it is to repair them.
Hmm.
That's incredible. I don't necessarily like it, but it's incredible. You have to admit, it's absolutely astonishing. I don't know. So 1,000 years from now, I hope your kid figures out how to make people live longer because I want to be around to see how that looks like.
I just wonder if we're going to be biological. I mean, it's like,
Honestly, I don't really give a crap. I just want to see what happens. I'm curious. I'm really curious. So we don't nuke ourselves into oblivion, which is still definitely a possibility.
Yeah. Hmm. Well, I really appreciate the time.
Absolutely. It's been great speaking to you finally, Nathan.
I really appreciate it. And if you know anybody else that'd be willing to have a conversation, I got over 1,000 more days to go.
When is the launch scheduled?
Well,
The
my
Artemis 2,
countdown's
right?
always been to the end of 2024, regardless of what comes.
Oh, yeah, you got a lot to fill.
Yeah.
If I run across anybody that'd be willing to, you know what, I could think of some people. I'll put some names your way, or I'll send some people your names, your name. You have one name.
That would be awesome.
Yeah, definitely. Space is cool, man. Thanks for making this happen.
Thank you. Have a good night.
Absolutely. You have a great night down there in Texas.
Okay. Bye-bye.